Good evening and welcome to your second video in your Chapter 9 series. Today we will be looking at how we use the stoichiometry that we've been working with over the past couple of days. We are going to do this as we start looking at limiting reactants. So what are limiting reactants? Well, limiting reactants are reactants which limit the amount of reactant that will react and the amount of product that can be produced. So what this means is that in our equations we are going to be given a couple of different numbers. So we are going to have two givens instead of just one. So we're going to have numbers in our equations for both of the reactants that are going to react in the equation. So what we're going to do is determine which one of those numbers is the number we're going to use for any other problems involving this reaction, because one of them is going to limit how much we use and how much we produce. The other reactant then is our excess reactant. So this is the one that isn't completely used up. We have more than enough of it. We don't need as much there. So rules to determine your limiting reactant. Just because it's a different type of reaction, it's still a stoichiometry problem. So the first thing we need to do is balance the equation. Then you're going to go through and do your stoichiometry problem. In this case, you're going to take both of those given numbers and you're going to change them into one of the products. Doesn't matter which one you choose, pick one. Whichever one's easier to work with. Then you're going to look at those two numbers. The reactant, which produced the least amount of product, is your limiting reactant. That means the reactant which produced the most amount of product is going to be your excess reactant. So you always, though, must compare apples to apples. So you must pick the same the same product that you're going to change both of your reactants to. You can't change one reactant to the first product, the second reactant to the second product, because then you really can't compare because their ratios may be different. So we are always going to compare them to the same product. So again, pick your product. Then once we have determined the limiting reactant, any further problems that we use with that equation is going to use or start with that limiting reactant. So basically we're going to narrow down our two given numbers to just one number that we are going to use over and over and over. Hello, good evening and welcome to your last video in Chapter 9. Tonight's video will cover the idea of percent yield. Okay, so let's take a look at percent yield. To find percent yield, we need to know two different numbers. Our first number is going to be a theoretical yield. A theoretical yield is basically a theory, or in theory, why we call it theoretical, what you should get as a result of this reaction. So this is the maximum amount of product that you should be able to produce. This number is always going to be calculated through a stoichiometry equation. So you're going to have to go through and do the steps. This may mean you have to do some limiting reactant stuff first, but you're still in the end going to do a stoichiometry equation to calculate an amount of product. The other number you're going to need is an actual yield. This actual yield is a measured amount of product obtained through experimentation. Since we're not going to have you do every experiment to get your numbers, this is usually given on your worksheet. So this will be a number that is given to you. For example, you just did a lab. In your lab, you went through and you got an amount of NaCl. Theoretically, you know what you should have gotten. How did that compare to your lab? I think that was actually one of your lab questions. So then if we wanted to, we could actually determine the percent yield of your lab that you did. We could take the actual yield, how much NaCl did you actually produce, and divide it then by the theoretical yield. How much, given just the equation, having no room for sources of error, none of that plays in, what should you have gotten? And then, of course, because it's a percent, we're going to multiply it by 100.